Okay, geometry kids, I had to leave at noon today because I don't have daycare for my kids, so I'm going home with them. But I'm going to run through 5-1 notes with you. Jalen should have your homework sheet for this, so please get that from her. And then Erica and Libby, if you guys are back today, you get those the notes and the stuff that we did yesterday from her as well. So I'm going to run through 5-1. It's pretty straightforward now that we know, circumcenter, in-center from yesterday when we constructed it, but I'm just going to go through just kind of like how to find the circumcenter, in-center. So like we look at the sides and we do the perpendicular bisectors of the sides to find the circumcenter. So I'm just going to do one of them, and like this bottom one, if we're bisecting, we're splitting in half, so I'm going to find the halfway mark, and then I'm going to make a perpendicular. So I'm going to draw a straight up and down vertical line, and this is bisecting him. It's cutting him in half, so I'm going to do those 2 hash marks, and then I would do that same thing for each one of the other sides and find the circumcenter in the middle. Okay, I'm just going to show the one that's there for right now, but the circumcenter, we would just do that for all 3 sides and find that middle point, okay? The in-center is going to be bisecting the angles. So if I just do one of those, I'm going to take like this angle over here in the corner, and I'm going to split it in half. And this would be the same as that, so I'm going to do those 2 tick marks. And I would do that for every single one of the angles, like split this angle in half, split this angle in half. And this place is going to be that in-center, which is where those guys come together. So we just kind of went over that yesterday. We filled that in, and then this is just some information about it. So over here we're going to be solving some things, but they went back through and they talked about, in particular, like if I take segment AB across here, we know that this line going this direction is splitting it in half because of these 2 tick marks. So we know that this length is the same as this one, but it is not making a perpendicular. So it is a bisector, but it is not a perpendicular because it's not making a 90-degree angle right here, okay? If we go over to this segment, JK, this segment across here, my RS line, is splitting it in half because it's the 2 tick marks, but it is also perpendicular because it's making that 90-degree angle. So he is a special type of bisector, like the ones that we were talking about here when we did circumcenter. Special type of bisector because he is doing a 90-degree angle with the segment that he's bisecting, okay? I'm going to skip this box over here, and let's just go through the examples, and we'll see if we can kind of figure this out. We are talking about perpendicular bisectors, and so what they're saying here is that AC is a perpendicular bisector, and we can see that because he's making a 90-degree angle and he's splitting this in half. But one thing that I also know is that that perpendicular bisector is going through the vertex A, which it doesn't always. Like up here when I bisected this one, this line did not go through my vertex at the top, okay? But it only does that if this triangle is an isosceles triangle. So if it's an isosceles triangle, that perpendicular bisector is going to go through that vertex, which means that if this length is a length of 4.1, then this is also going to be 4.1 because it has to be an isosceles triangle. So when they say find the measure of AB, AB is going to be 4.1 also because we know it's an isosceles triangle. Okay. Now going back the other direction, in B, we know that this is my perpendicular. We don't necessarily know it's bisecting because they don't give me the 2 tick marks here, but we know that if this is 9 and this is 9, then this has to be an isosceles triangle. And so they tell me that YZ right here is 3. I don't know if you guys can see that very well. But if that's the case, then this has to also be 3. So it goes back the other direction as well. If they give me these 2 measures are the same, then that means these 2 measures have to be the same because it's an isosceles triangle. So WY, this segment here, is going to be a length of 3. Okay, going down here for RT, this is my perpendicular bisector, and we do know that it's bisecting because those 2 segments are the same. So again, this is an isosceles triangle because it's going through the vertex here, which means that this side, which is 2x plus 3, and this side, which is 4x minus 7, those 2 sides are going to be exactly the same. So we can set them equal to each other and then solve. So I'm going to add the 7 over. And I'm going to subtract the 2x. So we have 10 is equal to 2x, and x is going to be 5. But they want to know what RT is. And RT is like this length here, so I'm going to plug that 5 back in to the x, okay? So 4 times 5 minus 7, this is 20 minus 7, or like 13. So 13 is going to be the measure of RT, okay? If I'm going way too fast, please stop, back up, and you know, you can write that stuff down, okay? One thing that we talked about was circumcenter yesterday was that when you're trying to find the circumcenter, okay, we bisected each one of the sides. So if I'm looking at this bottom side, I use this line to cut it in half, but also at a 90-degree angle, and then I do that for each one of the sides. So this guy right here is bisecting this at a 90-degree angle, and this side right here, this guy is bisecting that at a 90-degree angle. So this is going to be my circumcenter, okay? But that circumcenter, that point, is going to be equidistant from all of the angles, which is kind of weird because those aren't the lines that we drew originally, but that's just kind of a unique quality about circumcenter, is that he's the same distance. So if I have like Blue Hill over here and Hastings over here and Lawrence over here, and I'm trying to find the center, bisect the sides, and then you get the point right there that's exactly in the middle, okay? Now that is, so for circumcenter, it is the middle of the angles, and I think we wrote that on a paper yesterday. It's the middle of all the angles, okay? So for an acute triangle, the circumcenter is going to live somewhere right here, you know, like hanging out in the middle, maybe not quite what looks like to be the middle, but you know, somewhere there where he's equidistant from all the angles. If you have an obtuse triangle, though, let's look at these guys, thinking about them like in terms of towns, okay? So if those are my 3 towns and I need to pick a point that's in the middle of them, okay, that is exactly the same distance from all of them. If I pick like a point right here, you know, that might be the same distance here to here, but this person's going to have an advantage because they have it closer, right? So when the triangle is obtuse, what we know is that the point that's equidistant from all of them is going to be a point that lives outside of the triangle. So it's not even inside the area between them all, it's going to be outside here. And that just makes it so that this person doesn't have like an unfair advantage or is closer to the other one, okay? So for an obtuse triangle, it's going to be outside of the triangle, and it's still, we're doing the perpendicular bisectors. So this line is still at a 90-degree angle for this guy. This line is still at a 90-degree angle, and this one is still at a 90-degree angle for this one. So we still do the perpendicular bisectors to find that. It's just that dot, the circumcenter, will live outside of that triangle, okay? If we have a right triangle, meaning a 90-degree triangle to start with, we do the perpendicular bisectors, and that point is going to live on the edge of the third side, okay? Which means that like this distance and this distance and this distance, those 3 are all going to be the same length, okay? But that dot is going to live actually on the third side, on the hypotenuse side. So that's something that we didn't talk about yesterday because we only looked at acute triangles. We only looked at like this scenario, but that can happen, and that will happen if you have an obtuse or a right triangle, okay? Let's go down here to the top of the second page. We are using the circumcenter theorem, and what they're saying in this diagram here is that we have a sink. This is a sink. They use sink because stove was already labeled S, so they use sink to be K. And then we have a refrigerator. These are all in our kitchen. And what we're doing is we're trying to find like an island or a table or something to put in the middle here so that it's exactly the same distance from all 3 of them. So I don't know, maybe I put it like here. I want that to be the same distance for all 3 of those, okay? So we know that if we construct the circumcenter, that it's going to be the same distance from all 3 of those. So this is just more practice of what we did yesterday. We're going to bisect all of the sides. I'm going to look at this side first, and I'm going to split them exactly in the middle, and then I'm going to make a 90-degree angle. And you can use your note card. That would be a really good idea to make him a 90-degree angle. And I'm going to do the same thing for this side over here. So I'm going to split him exactly in half and make him a 90-degree angle. And again, use your note card if you need to make that 90-degree angle. And I'm going to split this guy in half and just hope and pray that they all come together at kind of the same, yeah, they do kind of come together at the same spot. So I did it somewhat right. And this is the circumcenter. Circumcenter. And that's going to be where my island is going to be located. or my table or whatever. So it's exactly in the middle. So even though we bisected the sides, this distance and this distance and this distance will all be the same. Okay, and that's kind of what a circumcenter does. Okay, now we're going to switch gears and we're going to talk about the in-center, which is bisecting the angles. So not talking about sides anymore, we're bisecting the angles. Okay, so here we have this going on, this diagram right here, and they want us to find XY, which is this length. Okay, and one thing that I noticed from this diagram is that this is 41, this angle, and this angle is also 41. So this line is in fact bisecting, it's splitting that overall big angle exactly in half. They're each going to be 41s, okay? And if we have this segment perpendicular to this one, and that has a length of 7, this segment that's also perpendicular will also have a length of 7. It's like if the angles are the same, the lines are going to be the same as well, as long as they're perpendicular, okay? I had somebody kind of confused about that, and they're like, well, those shouldn't be the same. If this from here to, like, let's say here, you know, this length is obviously not going to be the same as this one because this isn't at a 90-degree angle. You know, this is going to be obviously longer. But if we put it at a 90-degree angle with this side, this length here will be exactly the same length as that one. So they will each be 7. Okay, now they're going to go backwards, and we know from this diagram that we have a line going through here, and maybe it's bisecting, maybe it's not. We don't know if this angle is necessarily the same as this one, but what we do know is that this perpendicular, again, 90-degree angle, has that tick mark, and this perpendicular 90-degree angle has that tick mark. So they are telling us that this length is the same as this one, kind of the same scenario as what we had over here, but in reverse. Don't look at the way that this diagram is set up because this side obviously looks bigger than this one, so don't look at it too closely. But if they're telling me that those two are the same, then these two angles have to be the same. So if that's 37, then this has to also be 37. And so JKL is this little piece right here. That's the missing angle. We can say that it is 37 also because that has to be a bisector if each one of those, I don't know what I just did, if each one of these little pieces is the same right here. Okay. Part C, SP. SP is this guy right here. Okay. Now, in the last two problems, we were saying that this one is the same as this one, so we can certainly set those equal to each other, but we only know that that is true because these two angles are the same. So looking at those two little bubbles, that fact is what makes these two the same as each other, okay? So we are able to say 3x plus 5 will be equal to 6x minus 7, but only because those angles are the same. So let's go ahead and I'm going to subtract the 3x over here, and I'm going to add the 7 over here, and that makes 12 equals 3x, and x will be 4. But that's not what they're asking. They're asking me to find the length of SP, which is this guy here. So I'm just going to take 4 and I'm going to plug him in. 6 times 4 minus 7, 24 minus 7 is 17. Again, if I'm going too fast, please pause. You can get all those notes written down, and we'll move on to the next thing. So we've got one more thing yet. And on your homework assignment, pay really, really, really close attention on, like they have sections on your homework assignment that will tell you, they'll give you like a big diagram here. And they'll say, find some things, okay? What I want you to do on your homework assignment is look at the instructions, like where it says example, whatever, and circle whether you're finding the in-center or whether you're using the circumcenter, because that information is going to tell you a ton, okay? So this guy is an in-center. This centerpiece right here is an in-center, which means that circumcenter tells you one thing, in-center tells you the other thing. So if this said the circumcenter, then that would mean these three distances from here to here to here, those would all be the same. That's true if it's a circumcenter, okay? But because it's an in-center, this guy is saying all three of these lines are the same. That's what an in-center does. And an in-center also tells me that each one of these is the same as each other, right? So if that one's 34, then this one has to also be 34. If this one is 32, I'm going to put 2 lines there, then this one's also going to be 32. Okay, this guy down here, we don't know what he is, but we do know that those 3 have to be the same. Okay, or those two sides have to be the same because it's bisected. Okay, that's one thing that they're going to ask me in part B is JAC. They say find the measure of J is this middle one, JAC. So they do want me to find this little bit right here, okay? So one thing that we looked at first period was we said, okay, let's look at this overall big triangle, okay? Because there's a bunch of lines going on in there, but let's look at that overall big triangle, okay? We know that this angle plus this angle plus this angle has to add up to be 180, okay? Angle B is this whole thing, which is 68 degrees. If I add those 34s together, that will be 68. Angle C will be 64 if I add those two 32s together, okay? And 68 plus 64 ends up being like 132. If I subtract that from 180, I end up getting like something like 48. So that means angle A has to be 48. So this whole thing right here is 48, okay? Which means that if it's bisected, each one of these is going to be 24, right? So I can say that angle JAC has to be that 24 degrees that I'm looking for, okay? So that's kind of how that works out for the angle-wise, okay? I'm going to erase a bunch of stuff. And if you didn't want me to erase it yet, go pause the video at that point and it will stay on your screen. I'm going to move on to JF. What we're trying to find is JF. So we know that this is the in-center. JF is this guy. So we know that that one is the same as this one, and that's the same as that. So we know that those, like, it kind of looks like a little wind turbine. Those guys are all the same length, and they want us to find this. So if one of these was labeled, that would be great, except they're not. The only sides that are labeled is this is 15 and this is 12. But if we look at like this guy as being a right triangle, we can use the Pythagorean theorem to find that side, right? So like a squared plus b squared equals c squared. Okay, let's say 12 is A and then 15 is going to be C, and this guy is going to be my B side. Okay, so we have 12 squared plus B squared equals 15 squared, and then we can use that to find that third side. So 12 squared is 144 plus B squared, 15 squared is 225, and if we subtract that, 225 minus 144 is 81, and we take the square root, and that is 9. So we know that this length is 9, but we already said that wind turbine thing is going on. So that means JF, what we're trying to find, is also 9. Really, this guy's 9 as well. So JF is going to be a measure of 9 inches, 9 whatever units it is, but that's the length of that. Okay, so pay attention to whether they're saying in center or circumcenter, because that's going to be hugely important in your homework assignment. Okay, if you have your homework paper with you, here's what I want you to do. We kind of cut this weird first period on the practice side, okay? Rather than me saying evens or odds or whatever, like a lot of times you get down here to these sections, and if I say evens, it's like, okay, well, we'll do 8, but then we would have to do 7 in order to do 8. So we do chunks. So we're not going to do it that way. What we did first period is I said, okay, practice, let's do these 6, right? Do those 6 on practice. And then on skills practice, so you can skip all the stuff down here, and they're like, yay, no story problem. So do 1 through 6 on practice, but then on skills practice, do 7 through 12. So you do those 2 chunks there, okay? So we kind of just, avoided like having to do evens or odds. So you can skip this chunk, do that one, and do this chunk. Okay, so hopefully that made sense. Skills practice is 7 through 12. Practice is 1 through 6. It's not a whole lot of problems, like 12 problems, but really pay attention to, like on 7 through 12, 7 through 9 is the circumcenter, 10 through 12 is the in-center. So that's going to tell you different things, okay? All right, hopefully that made sense. Sorry I couldn't be here today, but I'll go through any questions on Monday.